In today class, I'll explain about binary search tree. Then what is binary search tree? What are the operation to be performed on binary search tree? And what are the advantages and disadvantages of binary search tree? Then binary search tree is a binary tree. The data can be organized in the particular order. Then how the data can be organized in the particular order? Then you can see the three basic properties. Here, the left node or left subtree is less than the root node, then all elements in the right subtree are greater than the root node. Then the third property is that both left subtree and right subtree should also be binary search tree. Got my point? The first property, the second property, then third property. All elements in the left subtree are less than the root. All elements in the right subtree are greater than or equal to the root. Then both the left subtree and right subtree itself a binary search tree. The keeping these three properties, then we can able to construct the binary search tree. Then here the valid example and invalid example. Here in the first example, all elements in the left subtree less than the root, then all elements in the right subtree are greater than the root. Okay, it is a valid one. Then when it comes to the second diagram, the 12 it is not placed in the proper position. The 12 actually it is greater than the 10 because all elements in the left subtree less than the 10. But here the 12 has to be placed in the left subtree. It is not in correct position. Then when it comes to the 9 is less than the 10, but it has to be placed in the right subtree. Then where it should be placed in left subtree because 9 is less than the 10. Okay, it is not a valid binary search tree. Then what are the advantages of the binary search tree over here? The searching is very easy. When searching is very easy, if it is a balanced binary search tree, then searching takes less time. Okay, if it is unbalanced binary search tree, the time complexity would be order of n. Okay, then I will show you example in the next slide. Then insertion and deletion are faster. Okay, so they are some of the advantages of the binary search. Now you can able to insert then delete an element from the binary search tree. We will see in the next slide. Here, the another way of representation of binary search tree in the memory. How we can able to represent a BST in the memory? This is the way because a node to be constructed, the node should be is a data part, then left child, then right child. Okay, once a node has to be constructed here, this is the left pointer, this is the right pointer. This is the left pointer, it is the right pointer. The left pointer would be connected to the left child, the right pointer would be connected to the right child. Okay, if you know linked list concept, you can understand this one. Okay, if you have any doubt regarding this, you can post in the comment box. Then I will take the separate class for the linked list. Okay, this is the way you can represent the binary search tree in the memory by using linked list. Then what are the operation to be performed on the binary search tree? Then insertion, the second one is the deletion, then third one is the searching operations. The searching is very easier in balanced binary search tree. Then insertion, deletion is also very faster in binary search tree. We will see one by one. Then how do you construct the binary search tree? Over here you can see this example 10, 12, 5, 4, 20, 8, 7, 15, 13. The elements as given as input. Then how do you construct the binary search tree? The first insert 10. Then always the first element would be a root element. Okay, it has to be inserted. Then what is the element next? 12. 12 would be compared with the 10. Then 12 is greater than the 10. That's why it would be inserted in right subtree. Then insert 5, the insert 5 would be compared with the root node 10. Then 5 is less than the 10, that's why it is placed in the left subtree. Got my point? Then when it comes to the next element 4, then 4 is less than the 10, which will becomes to the left side. Then it is also be compared with the 5. The 4 is less than the 5, then 4 is placed in the proper position. Then 20, then 20 is greater than the 10, then that's why the 20 will comes in right side, then 20 is also be compared with the 12. The 20 is less than the 12 because the 20 is placed over here. Then what is the next one? Insert 8. The insert 8 is less than the 10. It is placed in the left subtree. It is also be compared with the 5. The 8 is greater than the 5. The 8 is placed over here. Then like that, the 7 will also be inserted. The 7 is less than the 10 and 7 is also greater than the 5. Then which will comes to the right subtree of the 5. The 7 is also be compared with the 8. Then 7 is less than the 8. Then 7 is placed over here. Okay, like that, they can able to insert 15 also. 15 is greater than the 10. That's why it should comes in the right subtree. Then 15 also compare with the 12. Then 15 is greater than the 12, which will comes in the right side of the 12. Then 15 is also compare with the 20. Then 15 is less than the 20. That's why it will be placed in the left subtree of the 20. Like that, you should also insert the 13 is greater than the 10. The 13 is also greater than the 12. Here, the 13 should be compared with the 20. The 13 is less than the 20. It will comes in the left side of the 20. Then 13 is also compared with the 15. The 13 is less than the 15. Then 13 will be placed in the proper position. Okay, this is the way you can able to construct the binary search. In the next example, I will also be give you another example. 1, 2, 3, 4, 5, 6. If the element is like this in ascending order, then how do we construct the binary search tree? Then always the first element would be root node. Then here the 2 is greater than the 1. Okay. Here 2. Then 3 will comes to here. Then 4 will comes here. Then 5 is the right subtree of the 4. Then 6 is a right subtree of 5. Okay, the data is given as a input like ascending order. How we can construct the binary search tree? It is a 1, 2, 3, 4, 5, 6. Okay, this is called as the right skewed binary search tree. Right skewed binary search tree. Okay, this is the problem in the binary search tree. The data is given as a ascending order or descending order. The height of the tree would be increased. It will take more time for searching an element in the binary search tree. If we like this 6, 5, 4, 3, 2, 1. Then how these elements to be inserted? The 6 will becomes the root node. Then 5 is the left child because 5 is less than the 6. Then 4, then 3, then 2, then 1. Okay, these types of trees are called as what? Left skewed binary search tree. Okay, left skewed binary search tree. Got my point? Okay, the data has to be given either in ascending order or descending order. Then we can construct the right skewed binary search tree or left skewed binary search tree. Okay, then what is the problem in the binary search tree is the height of the tree will get increased. The tree is constructed like this. What is the time complexity is order of what is called order of n. In case of the balanced binary search tree, time complexity of order of what is called log n base 2. Okay, because this is the time complexity of the balanced binary search tree. This is the time complexity of the unbalanced binary search tree. Then the balanced binary search tree means it is either the height of the binary search tree would be 0 or 1 or minus 1, not more than 1. Okay, those types of trees are called as the balanced binary search tree. Okay, when you comes to the next slide, this is the way you can insert. Then how do you delete an element from the binary search tree? You have to remember whenever you want to delete the binary search tree, you can check three cases. The deleted node is a leaf node, the deleted node with one child, the deleted node with two children. Got my point? In the first case, I will try. Then, how do you delete a leaf node? Which means that the leaf node does not have any children. In case of the deleting node, what is called in case of 19. Okay, in the 19, it is not a 9, it is not 85, 19. The deleting node is 19, does not have any childrens. Then how do you delete that kind of node? Okay, that parent link part would be null. Here, if it is null, then it will be disconnected to the node 19, then it will be deleted from the memory. Okay, once it has to be deleted, how the tree will be constructed, the tree will be displayed like this. Okay, here it is would be null. Okay, this is a way you can delete the leaf node. Then the second case, the deleting node with one child. For example, in case of the 9, okay, if you want to delete the node 9 from this binary search tree, it has the parent node and it has the right child. Okay, then what you have to do in case of this one, the right child, okay, link to be replaced over here. The child, deleted node, child node would be connected to the deleted node parents. Okay, this is the way we can connect. After that, this link would be disconnected, then new link will be established. Okay, once new link 7 directly would be connected to the node 9, then this is a resultant tree. Okay, because it is our whether deleting node has one child, it is a left child or right child. Okay, you check it once, then how do you remove that kind of node from BST? Then the deleted node child node would be connected to the deleted node's parent. Okay, this is the way you can delete a node. After that, once it connected, it will be disconnected, it will be deleted from the memory. In the last case, the deleted node which has two children. Okay, then how do you delete a node with two childs? In case of 45, is as two children, then how do you delete that node? Okay, there are two ways to delete a node with two children. Then either you find the minimum value in the right subtree or maximum value in the left subtree. Because here it is a left subtree, got my point? Because it is a right subtree. Then what you have to do here? Then maximum value, in case of maximum value in the left subtree, then R minimum value in the right subtree. Either you go for the first step or second step. Here, if you want to move here, it is followed in order successor. 45 is replaced with in order successor because then you find the minimum value in the left subtree. What is the minimum value in the left subtree? The 55. Then 55 will comes to here. Okay, 55 will comes here. Then 45 will comes here. Then after 5, this node to be deleted. This node to be deleted. Here, okay, it has to be done. The 45 will comes here. Then 55 will comes in the root node. Then 45 will comes here. Again, this node to be deleted. Node to be deleted. Here, this is the way you can delete a node with two, or else to find the maximum value in the left subtree. Or else, what is the maximum value here? 20. The 20 is replaced with the 45. Then here this node to be deleted. Either you go for the first step or second step. Got my point? Then you find the maximum value, minimum value in the right subtree or to find the minimum value in the right subtree. Then replace that node with the root node and that node to be deleted. Got my point? This is the way you can delete a node with two children. Thank you all for watching my videos. If you have any queries regarding the implementation of the binary search tree, you can post in the comment box. I will help you out. Thank you all. Thank you for watching my videos.